Hello everyone, and welcome to today's webinar, Best Practices for Efficient Energy Management, a Cassidy Turley Case Study. I'm Ann Vasquez, the editor of today's Facility Manager, and this webinar today is presented by Aquicore. Now before we get started, I'll cover a few housekeeping items. First, please note the control panel that's on your screen, and this is where you can submit questions throughout the presentation. There's a question box in that panel. You can send these in at any time, and our speakers will be addressing them after the presentation. Also, please note the orange arrow on the left side of that control panel. Clicking on that arrow will either expand or collapse the panel, so please be sure that it is expanded so you can access the question box. If at any time you experience a technical difficulty, please send a message to us right in that question section, and we'll address your issue right away. So let's get started and meet today's speakers. Founder and CEO of Aquicore, Logan Soya, is an expert in data collection, data management, and operations management software. For 6 years, he designed, implemented, and sold numerous multi-million-dollar operations management platforms in the IT and telecom industries, both domestically and internationally, for high-profile operators. Passionate about improvement through technology, Logan founded Aquicore in 2011 to bring his expertise in data collection and analysis into the commercial building industry. Logan received his MBA at Georgetown University and London Business School, an MS in Systems Management, and a BS in Physics. Recognized by BizTech Now as one of the 30 under 40, Logan brings expertise about how the Internet of Things, economical submetering, and centralized energy information will change the building management industry in the next 5 years, and how to take advantage of it. Our other speaker today is Lee Dunfee, Vice President in the Engineering Operations Group with Cassidy Turley, a national full-service real estate services company. Lee supports operations and leads the energy management programs in the eastern U.S. for Cassidy Turley. His responsibilities include setting overall energy reduction goals, setting up energy-saving strategies for buildings, and developing in-house training programs for smart operations. As a certified energy manager, certified demand-side manager, and lead AP, he also conducts energy audits, oversees retro-commissioning efforts, and supports Cassidy Turley's in-house sustainability team with lead projects. Now, before we begin, I would like to pose a question to all our attendees in the form of a group poll. So please take a moment to cast your vote in this poll. This is a multiple choice, so you can select one or more, all that apply. And the question is, what type of energy data collection do you use today? Please take a moment to check all that apply. Okay, so let's see what our results are here. Our leading result was 52% of our audience said they're using real-time metering, at this point. So, okay, thank you for sharing that with us. Now I will turn it over to our first speaker, Lee Dunfee. Lee?
Before we get started, I would like to just give you a little bit of background on Cassidy Turley. As Ann said, we are a national full-service real estate provider, providing brokerage services, leasing services, property management, sustainability services, project development, and facility management services across the U.S. We have over 400 million square foot under management. It's mostly all third-party managed, which really is a key component to our hit the ground running, collect some fast energy data, because we often pick up projects rather quickly. We have 450 buildings benchmarked in Energy Star. We were recognized as Energy Star Partner of the Year in 2013 and 2014, and we're moving towards sustained excellence in 2015 if we can get one more year. We've completed 55 lead projects where energy management has played a key role in the successful execution of those projects. Last year we had 60 buildings in the EPA's Energy Star competition for Battle of the Buildings. 4 of those were recognized as reducing greater than 20%, and in 2014 we have 125 buildings already registered for that competition. Now a little on the topics that we'll discuss on the next slide. So first we're going to talk a little bit about measuring, and we're going to focus on 2 ways. We're going to focus on Energy Star benchmarking, which is really the long-term improvement of energy performance. It's a great, powerful tool. We're going to talk a little bit more about that. We'll use this measurement data that we get to really establish the targets, how large or small our target should be. So we're going to talk about Energy Star data. We're going to talk about real-time metering data and how useful it can be in helping establish those targets. And then we're going to talk about using that data to really engage the entire team at the property, and how helping folks understand that data can really move the entire property team forward. We're going to talk about how to analyze that data. We're going to look at some live data, real-life screenshots, and understand things to look for in that data, what to do, what not to do. We're going to showcase one of our success stories on how we used real-time data to achieve some great success and some great reductions. Then we're going to talk a little bit about future potential, how the data can be used to predict future results and stay on track. One of the first things we want to go over quickly is Energy Star benchmarking for a building that one of the projects that we took over in the Baltimore area. So we took over the project. We benchmarked the building, and accurate benchmarking was key to that. I mean, I'll emphasize that throughout this presentation, that accurate data is key to being successful. Energy Star benchmarking it's a free tool provided by the EPA. It's recognized and respected nationally and internationally. The Energy Star logo is pretty commonplace on anything from appliances to buildings. The great thing about the data, it is weather normalized, and it's used for many different type of buildings. So it can be applied to a school or an office building and such. So what would you need to do to get Energy Star benchmarked? You would need 1 year's worth of energy data and some basic info about the building. Things like population, how the space is being used. Is it office? Does it have a data center component? Does it have a retail component? Does it have a conference center? Those types of things. And once you put all that data in, what you would get out is really where the building stands. So it would really help you establish the target that you want to move towards. A higher scoring building, of course, the target might not be as aggressive. A building that scores a low Energy Star score as this one, this building that we're highlighting here started with a 26. The KBTUs per square foot were 171,000.3, which is quite a bit. Next, we'll dive in a little bit deeper on setting those targets and what that all means. So in 2009, we already talked about, we had an Energy Star score of 26. There's our average kilowatt hours per square foot, over 833,000. Demand, the peak demand the average was 915 as well. I'm sorry, 1,915 kilowatts as well. So given that, we set a pretty aggressive goal of 20%, given that performance of that building, and we thought 20% was a pretty aggressive goal. We thought there was a lot of room for improvement. We started looking at interval data, we started looking at real-time data, and we saw some pretty glaring opportunities for improvement. So we set a pretty high goal of 76. So we understood the current performance, we set our goals, and then we started to measure our results. And about 1 year later, we had already achieved an Energy Star score of 75 and received the Energy Star Award, where average kilowatt hour usage ended up well lower. It's a 42% reduction. And also, we didn't focus a lot on the peak demand of that building, but we were able to reduce it down into the mid-1700s on the KW. So it was a great next story. It was a great success story for us. So I want to talk a little bit now about some next steps in how you would get started. We talked about some of these. I'm going to dive just a little bit deeper. We set baselines for normal operation. So what that means is understanding the normal base loads, the normal weekend loads, and we use that 1 year we used the energy data from Energy Star. We also started to use the real-time meter data. We took a really hard look at start and stop times, what was going on Saturdays and Sundays. Took a really close look at base loads. And then this particular building had some really elaborate energy efficiency strategies built into the building automation system that did need some fine-tuning. So that's one of the areas that we focused on. So we tried to limit, maximize the use of the economizer, limit heating and cooling at the same time, those types of things. So we collected the data, and then we sat down with the operators and said, here's what we see, here's what we would like to change. Those were things like relaxed start times, shutting down sooner, minimizing weekend run times, starting to dissect that base load at night and on Sunday afternoons, what makes up that base load. So then we set some reduction goals. So we started to use this information to really tell a story, to win approval to move ahead with some of our energy initiatives and thoughts that we had. Changes in strategies, rewriting some of the automation system programming, relaxing start times. So instead of starting at 4 a.m., you may start at 7 a.m. So then we started to really highlight some of those immediate results. So we were quickly able to look at, say, the past 3 Mondays before our initiative started, look at the consumption on a typical Monday compared to a Monday after we started to make these changes. And we started to immediately show results. And it's a powerful tool when you can say, here's where we were, here's where we are, and here's the benefits of that. There's a financial component, and there's also an equipment life expectancy component as well, and a tenant satisfaction component. So we identified those operational changes, and we involved the entire staff to do it. And we always start with the most senior manager of the property, and we really meet with every aspect of the teams at that property, from security staffs to housekeeping staffs, because they're typically there after hours. So they have a really good understanding what happens and what they really need to make the building operate in the evenings and at night. So next we'll talk about why we would meter first on the next slide. So why meter first? It's fast and affordable to deploy. I mean, we're talking a few weeks to get this up and running and have real-time data streaming on your desktop. You get immediate access to the energy data that you need to make those operational decisions almost week to week. So you get it 1 week, and the next week you can start making those changes. It really provides great insight on understanding if building systems are operating as you think they're operating, as they're expected to operate. Are economizers working correctly? Are we using mechanical cooling when we have favorable outside air conditions for economizing? Are we using electric heat in the summer? Those types of things. Very easy to identify with real-time data. It's quick and easy to access from anywhere. So any smart device, laptop, tablet, you can pull up this real-time data and it's there. So it's very quick and easy to deploy. So it really gives your building a pulse to listen to. It verifies those sequences of operation that you would expect are in place, highlights operational inefficiencies, reveals peak and load patterns, peak and base load patterns, so you understand when am I using most energy, when am I not using so much energy, why does my Sunday afternoon look much better than my typical base load at night, what am I doing differently on Sundays than I'm doing on my weekday nights. And it protects equipment as it extends its life. When equipment is operating correctly, it will last longer, mechanical cooling is running less, and it's running more efficient when it is running.
Okay, thank you, Lee. This is Ann again. Now we'll ask our audience to take a few minutes to cast your vote in a second poll that we'd like to pose to you. And the question is, who reviews and analyzes energy data in your company? You can select all that apply, please. The choices are building engineers, facility managers and portfolio managers, building owners or asset managers, external consultants, or other. Okay, so let's see. 65% indicated facility managers and portfolio managers. Well, leading that, following that was 37% building engineers. So thank you for sharing your insight on that. Now we'll turn to Logan Soya.
Thank you, Ann. Next slide, please. So I'm going to take just a few minutes to chat quickly about, what does it take to get real-time metering into your facilities, and, what are the major components that we need to discuss in terms of implementing it and getting up and running. And really it consists of, in this kind of next generation form of metering, two components. One is a web-enabled meter that gets installed on site onto your facilities, typically right next to the utility meter in the building. And two is a software-based service. The reason why we go with this approach over any of the other alternative methods that are out there available today is because it just turns this into an extremely fast and extremely affordable solution, meaning that the time it takes for you to get to your value, which is analyzing data and taking corrective action, is far faster than any other method. Some of the reasons why these two components put together gives these benefits is, first, that it's web-enabled, meaning that you don't have to go on site to read a manual meter or an LED screen anymore. There's no BMS integration, and that actually is a benefit in the long-term scalability. As you're bringing sites on at a faster and faster pace, that means that there's no design time, there's no integration time involved, right? Literally is a walk on the site, find out where the utility meter is, and connect to it, a type of thing. And of course, the benefits of any cloud-based software apply here, meaning that it's accessible anytime, anywhere. There's no sort of maintenance or IT hassle, and you're getting free upgrades as well. One last kind of comment about these meters is that from an IT perspective, they're designed specifically to be pretty much plug and play, so that if anywhere in the building you can get Google or LinkedIn on your website, on your internet, on your laptop, that means that these meters can work and can send you the data that you need. Next slide, please. So what would it take to actually implement these? It's pretty straightforward, pretty simple. We like to collect a little bit of information just about your sites and scoping it, but it doesn't take much. First, we'd like to understand, are we looking at just a single site or a single building, or are we talking about several buildings? That's beneficial because we'd like to understand how you're going to be using the data, number one, and number two, there are some benefits that we can take advantage of if there are multiple buildings that we're discussing. Always good to know what's your total square footage that you're going to be addressing and that you're going to be metering this data with. We of course want to know how many points that we want to meter, so how many utility meters. And one thing I'll mention is that the topic of this discussion is primarily around electricity usage, but that doesn't preclude water and gas down the road, and that can be a more advanced topic as well. So that's certainly a possibility if you're wondering. And then the last point that we want to make sure we understand is referral to that question that we had just asked earlier, is who is the one that's going to be using the data and how are they going to use it? And we want to make sure that the data is clean, clear, and presentable, and focused on the right questions based on that user and what their daily role is within the facility. Next slide, please. So, bottom line, here's a quick summary sheet. Although all installations and all buildings are unique, this is a pretty good benchmark for you to get a good sense of where the costs are. Really extremely reasonable given the amount of value and the opportunity for savings that you can identify. First, the cost always has two components. There's an upfront metering and equipment cost that's typically in the $1,000 to $2,000 range. And then there's the actual ongoing service to be able to access the data and be able to report it. typically somewhere in that 200 to 600 per month type of range. Certainly, there are different payment options available, and also that depends on what types of features and components you're looking for. All in all, with those two components, you're really looking at a great result. Most buildings exhibit an 8 to 20% savings if you're transitioning from never using real-time data to now using real-time data, and that very often comes at a less than a year payback. So great returns, great opportunity here. Implementation time is, as Lee mentioned before, very quick. That's because it's web-enabled, because there's no upfront design and system integration. Typically, we're up and running and showing you real-time data in less than 2 weeks. And then once that data is accessible, we love to make sure that we go through the process of training all of the staff persons and all of the users appropriately. It's always important to acknowledge that human component and make sure that everybody's on board, number one. Number two, we then can set up alerts and maintenance notifications so that this tool is useful not only when you're logged in, but also can warn you when you're outside of the building and become sort of your assurance net that things are operating the way they should be. And then, of course, a monthly review pattern is always a huge help to review how the month has occurred and what corrections were made during the month with the real-time data. Next slide, please.
It's Lee again, and I'm going to dive a little bit deeper on some of the same topics, and we have a couple really cool slides coming up right after this slide, which shows us some really screenshots of true life data. So we'll take a look at those. So we talked a little bit about schedules, start and stop times, and there are two things to really think about when it comes to start and stop times. Start times should never look the same in July and August and January, February as they do in September and October and in the spring. We see swings of start times range probably in the 2-hour, sometimes push 3-hour difference. So we may start at 4:30 to 5 a.m. in August when it's 100 degrees, and we see those start times get pushed as far as 7:45 when it's in the shoulder months of the year. So it's a great way to save energy. What a real-time data does is, from a distance, you don't have to wonder, did I start correctly today? Have I made those changes? The weather has broken. Am I doing things differently? You can see it from your desktop. So if you're managing a portfolio or you're watching a few buildings that you happen to have energy projects going on, you can see them start and stop times very clearly in the load profile. You have a much better feel for weekends, what happens on Saturdays. Many buildings operate on a limited schedule on Saturdays and maybe no Sunday hours. So you can get a snapshot of what's going on there. If there are retailers and restaurants component to the building that happens to be on the main building's meter that's being metered, you could get a real good feel for how much energy they are actually using on the weekends. Holidays, it's probably one of my favorite times to say, why did we run on the 4th of July? Buildings are supposed to be off in most cases. So it's an easy way to look over someone's shoulder and say, did we run on Christmas? How did we look on Thanksgiving? What happened on the 4th of July? If we have run times at all, they typically are pretty narrow on those days. That's really what we focus on schedules. Use of economizer in special building systems. It really highlights the fact that, yes, the economizer worked, and we're going to look at a great example for that coming up here shortly. But did we keep mechanical cooling off on that 51-degree day? Did we have electric heat locked out on that one December afternoon or 2 December afternoons where it hit 72 degrees? Had we had that strategy that's in place? Did it happen in the building automation system? Did we see a drop-off in the use of electricity? Heating and cooling lockouts, we talked a little bit about those. Heating and cooling at the same time is one of my favorite topics, where you can go into a building in July and it's 87 degrees and you can find heat running in a VAV box. Often, if you understand your cooling loads and you understand your mechanical load and what it would look like on your daily load profile, If you have simultaneous heating and cooling going on, it shows up on right on your screen. And you can set alerts to say, I know where my top is. I know where my max load is. If my chiller is running at 100% and my building's fully occupied, if I go beyond that, I must be using electric heat. Base load's one of my favorite topics as well. So base load's when the building's off at night or on a Sunday afternoon or anytime it's not operating, maybe on a holiday. But two things to look for in base loads is that deviation in the base load. What's the low point over a 4-hour, over from that 2 a.m. or from that 12:30 p.m. or 12:30 a.m. to 4 a.m. What was the low point? What was the high point? Do we see any pattern? Do we see equipment starting and stopping? So is there a 100 kW difference or a 30 kW difference? And what makes up that difference? Is it hot water heaters cycling? Is it retail tenants on the ground floor that have loads running that you wouldn't expect to be running? So it's when you start to delve into the base loads and you only look at them and look at the deviation in the base load. So when did it start? When did I hit my low point? When did my system start to come back online? Just great information. Next slide, please.
All right, so we have a few really excellent examples that Lee will demonstrate just a few minutes here, but for those of you who maybe haven't seen real-time interval data before, just a kind of a quick summary as to what you're looking at here. This is 1 week of data for a live building example that we have here for our purposes today. As you can see, the energy essentially raises and lowers based on the occupancy of the building for each particular working hours, workday. And you can see, for example, in the middle on the Saturday and Sunday, the lower load versus the higher load during the working weekdays. So as we mentioned before, this essentially looks like a heartbeat or a pulse to the building and gives you a sense as to what's going on. And I'll pass it back to Lee for some precise examples.
So we'll look at a couple of things. We'll look at maybe 3 things in this weekly load profile. And the first one we'll look at is on Friday. So on Friday, typically the building should have started in that gray band, which is right around 5:30, 6 a.m. in the morning. And you can see we had a bad start at 2:30. And anyone who's operated a building, no matter how highly technical the building automation system is, sometimes things just don't operate as expected, or things get programmed instead of typing a 6 in, a 2 gets put in, and then how long does it run that way? Well, this allows you to catch that type of thing almost immediately. So the second thing we'll look at is that Monday on downstream there. That was Memorial Day, and you can see here's what I see when I look at that. I look at that as a building that the HVAC system started up and ran as normal, but there were no occupants there to really make the rest of that load up, which you would see on a typical weekday. So the building ran, there was no one there, no plug load, no lights were turned on, so the load wasn't as high. But you can see the duration was pretty long. It was an all-day event. The building ran for 8 or 10 hours, and likely with no occupants in it. The other thing I'll highlight a little bit is in between those two is the weekend. You see a little blurb on Saturday. That looks pretty typical for a commercial office building. You typically have some loose hours on Saturdays. Sunday looks a little rough, and I would question, why do we have those couple of peaks? We had that nice low spot on Saturday night. What happened on Sunday morning? Is there equipment operating that wasn't expected to operate? So a few things that we would catch on a 7-day profile, and I review many of these every week, and it's one of the coolest part of my jobs is to look at profiles like this and really understand what happened. One more thing I'll point out on this slide before we move to the next, which is the 24-hour load profile, is how the building coasts down at the end of the day. So the equipment is clear. You can clearly see where the equipment shuts off. And then typically what you see there are the late workers kind of working late, leaving, trickling out between 6 and 10 p.m., and housekeeping's coming in, cleaning the building. The security's doing different functions. So the building doesn't drop straight down. It sort of drops down. Most of the HVAC equipment shuts off, and then it sort of angles out to the right as it finishes its load. Usually ends around 10 or 12 p.m., something like that. Next slide, please. So here we have a 24-hour load profile, and there's a lot of great data here. And we chose this one because it had a great temperature correlation to it. So we got to see how the building operated on a cooler night moving into a warmer day. And what I'd like to do now is just start walking through that. So the first thing that if this were in front of me, the first thing I would look at is the base load. So the base load is this portion right over here on the left. And I talked a little bit earlier about understanding those high points and those low points. So what happened around 3 a.m. or 2:30 a.m.? What caused that rise in energy use? Was something running that wouldn't expect it to be running? Something that could be turned off? Could it be building hot water, domestic hot water that's reheating itself, and really we could secure that? Is it water coolers? Is it elevator use by security? Just understanding what that load is. And then you can see that the base load went back to normal, and right around 6 a.m. The building started back up. And if you look down below on the red line, it shows the temperature. It was a nice low 50s degree morning. So that next tier is where the building operated on economizer. I'll highlight that for you in just a minute. There you go. So there's where the building started. It was 52 degrees outside, nice cool morning. The building was equipped with an airside economizer, and it operated without any mechanical cooling. So just fan ventilation. At the same time, electric heat was suspended on the VAVs as well. So now we're operating that building just about as efficiently as we can, and still keeping it cool and still keeping it maintained in a way where the tenants would be very comfortable. So we're not using mechanical cooling, we're not using electric heat for heating, we're really balancing right in between. And there's a lot of times in the spring and fall that this can be done probably 60 days worth. This has been a great June. I mean, we've had some opportunities in June. So now I'll show you the line now where we're going to look where the temperature finally reached 63 degrees. That's the break point at this building where mechanical cooling is enabled. So the outside air temperature hit 63, and it enabled the mechanical cooling system to come on. And now we get to see the load increase. The mechanical cooling is tearing up. More people were occupying the building. So the load is just gradually coming up in the afternoon, and it's just it's a typical day. So now we've kind of reached that typical day. We're still not using electric heat, so we're using mechanical cooling. We're not using any heat at the building, and now we're running at full load. Take that next animation. Oh, we forgot to talk a little bit about what if we didn't operate on economizer. So if the economizer hadn't worked properly and we used mechanical cooling, even though it was 50 degrees outside, there's the savings. That's where our load profile would have looked like if we wouldn't have been running on economizer. And now we can look at that full load, typical full load right there. Typical day, chiller's on, building's occupied. And then we see 6 p.m. the mechanical system goes off and the load drops down. And it has that very traditional look, that gradual slide into that 10 p.m., which is a pretty normal thing to see. That's when housekeeping's coming in, late workers are trickling out, lights in the building are still on. Eventually, as cleaning gets the floors clean, lights are turned off. Security's becoming more stable, and now we're at 10 p.m. and the base load really starts right around 10, 10:30, 11, 12, depending on the building. Next slide, please. So using real-time data, we wanted to, again, recap what we were able to do at this property in Baltimore. It wasn't, let's picture the building. It was an 18-story building, rather narrow. Brought it some of its own challenges, a lot of southern eastern exposure. So we increased the Energy Star score by 66 points in 1 year. Real-time data was a key part of that. It really ID'd what we needed to fix. We didn't focus a lot on demand, but we had an 8% reduction in average demand on the bills. Pretty significant savings there as well. A 42% reduction in kilowatt-hour consumption. And we reduced our metric tons of carbon by over 2,700 tons every year since then. And it just so happens, in this region, this building has the highest Kingsley's tenant satisfaction scores in our portfolio. So it really, we highlight that as you can operate efficiently, and you can actually keep tenants pretty daggone happy doing that. Next slide, please.
All right, so you know, I think we gave some awesome examples. I love listening to it every time. Some of the things that you can see out of this information that we can pull out of buildings. But I thought it might be helpful to kind of ask ourselves, what's next? What could we do beyond that first step? And just kind of highlight that a little bit. Two pieces, you know, worth discussing or worth having a conversation about as potential next steps. One is submetering. You can see it on the screen on the left side. In addition to that building level real-time data, we've actually gone a step further to be able to submeter, and this can be extremely beneficial to you know, to break out and actually locate and isolate where the problems are. So you can see all that information from your desktop, right? Don't need to walk the building or anything of that nature anymore at this point. And again, starts to help isolate and find these problems even more precisely. And the one thing that I'll mention and I'll raise in this point is that submetering is really becoming affordable now. That's something that historically kind of has been a challenge to be able to bring into a building at a cost-effective sense. But with these web-enabled meters, you know, we're looking at an opportunity here to be able to bring more points of data per building now. The second point that I'll highlight is the opportunity to centralize this building data. So, you know, you no longer you need to have this information that's isolated to a single building or a single campus. This information really can be portfolio-wide. You know, we have stories of you know, of real estate clients that have hundreds of buildings across the nation that all are able to centralize this data to a single place to be able to manage this information. And that adds additional features and additional capabilities beyond just individual building analysis. Now a portfolio can analyze building data and understand which buildings are their leaders, which are their laggards, and you know, which to put their attention to first and prioritize. And so a couple more advanced topics worth discussing, and certainly worth taking that next step on as you progress in your energy initiatives.
Thanks, Logan. This is Ann again. Thanks for that additional explanation. We're now going to take a moment to present a third and final poll question to you, our audience. And the question is, has your organization started centralizing its energy data? And if you can just share, select one of the following. Have you not started? Are you just beginning? Or is your whole portfolio centralized at this point? Are you further down the road? Please take a minute to share your status with us. Okay, so 55% have not started and 32% have started, with 14% looking pretty well in their centralization. So thank you for your vote.
Okay, I'll do a really quick wrap up here, just to kind of go over a few of the most important points. So start with Energy Star benchmarking. It's just a great free tool for long-term tracking. Normalizes weather, normalizes the space types and the operating hours. So if you have a building that operates 16 hours a day, comparing it to a building that operates 10, makes the playing field level. Just a great and powerful tool, and it's free. Real-time meters really just give you immediate actionable data that you can look at on a Monday and make changes the following Monday. it's just a great, powerful tool. And we highlighted one of our most significant success stories, but we have a lot of others really close behind that. Access to, just like Logan said, access to the meter data is really fast and affordable nowadays. It's not hard to get. It's quick to set up. It's not that expensive in the big scheme of things. Real-time energy data really does yield significant savings. I mean, like I said, we highlighted one of our best case studies, but we have many, many of them that are breaking the 25% range. And we really do feel like, I mean, many industry leaders are starting to, and the poll showed that they're starting to go to real-time metering, and really it's really becoming commonplace the way we do business. It's expected, and it gives operators the data they need to really understand, and it gives portfolio managers the data they need to make sure things are operating as they want them to operate. Next slide.
So, you know, Lee and I are constantly excited about this kind of stuff, and so for us, you know, we'd love the opportunity to help you out as best as we can to get the conversation started for you and be able to kind of move forward as easily and as best as possible. For those of you who have not done Energy Star benchmarking before, or really, you know, taken those steps into real-time metering, you know, thank you first of all for taking the time to be on this presentation, and secondly, you know, we'd love the opportunity to help you get started. So as part of that, you know, we're offering a free initial benchmarking and assessment that includes getting that Energy Star score taken care of. Please feel free to visit the website and sign up at aquicore.com if you're interested in that. And we'd love to talk to you more after this webinar is over.
Great. Thank you, Logan and Lee. We do have some questions that have come in, so we will turn to our Q&A portion of the presentation now. And let's see, we did get some questions about your project, Lee, some specifics, so I'll start off with that. You had mentioned involving on-site staff and other personnel. So can you just talk to us about, explain a little bit about how many people were involved in this building improvement process at 750 Pratt Street?
You know, I would, if I threw a number at it, it would probably be in the 7 to 10 range. It started with the energy manager for the site really built the case and presented it to the senior manager. We got approval to move forward with working with the building operators and conducting some training, meeting with the building automation system provider to make some operational changes. Security staff was there 24/7, so we used their eyes and ears to help understand what was happening at the building at night. They would also look for lights that were left on and such like that. Housekeeping staff as well, we asked them to put a routine together to say, when you're cleaning the building, we would like you to get the lights off as quickly as possible, even allowing them to start a little bit early to get mobilized, to get up onto the floors. So right when lease hours ended, they could literally hit the ground running quicker to get the building cleaned quicker and get lights off sooner. So all those members of the staff were involved. I'd say the key players were the operations staff, and really backed by the senior manager to say this is important to me, and also the client for the building, the owner of the building, was involved and saying this is a priority for me and I need everybody's support. So it was really ran the full scale there.
Okay, great, thank you. And just dovetailing on that for a moment, we had some people interested in asking what was the most challenging part of getting started with this process. I know you had mentioned, you know, the implementation, etc., but if you can just maybe cite an example or two of the challenges or even the highlights of you know, getting started with this.
Yeah, getting started was, we benchmarked the building. That was a big part of it. So we benchmarked it and we saw that 26. We knew we had some work to do. In my world, that's a lot of fun, to be honest with you. So that was exciting. I couldn't wait to dive in. And then moving forward with a real-time meter, probably say that, you know, in 2009, probably not as commonplace. So a little bit more of a stretch. I wouldn't call it a challenge, but we needed to all understand what we'd get from it, why we should do this. And then starting to collect that data and seeing things that weren't operating as we thought they were. Even though it had a state-of-the-art system, there were just a few bugs in it, that things weren't operating as expected. It was exciting that they were relatively easily fixed, and we had really, really quick results.
Great, thank you. And now taking a broader step back for a moment, we had some questions about basically once I fix the problems or the issues in my buildings, why should I continue to use real-time data? And if my buildings have an average Energy Star score of, say, 75, why would I need this real-time data?
Sure. So, I can take that one. I really think that, the value of real-time data is it keeps things in check beyond that initial audit. It's a way that ensures that, that dynamic environment of the building is kept in check. The reality is a lot of the things that Lee discussed and what we see in these buildings is the fact that buildings are dynamic. There's a lot of weather changes. There's a lot of changes based on, what the occupants are doing. And so, a one fixed formula and set it and forget it type of mentality, it isn't the best answer to be able to get the best results. It's really about being able to offer what I would call persistent savings, right? So that those savings don't erode month after month and year after year, and you're able to maintain those savings, and that's what this type of data can provide.
Okay, great, thank you. So then we had another question about, again, when you're bringing this into a facility, or when bringing this idea or this concept to a new facility manager, who are you finding is what objections do you hear, or maybe some concerns from facilities people? And then what might you say list are the top 3 reasons for doing it?
So basically top objections and top 3 reasons for doing it. Top 3 reasons, I'm going to do the top 3 reasons first. Fast results, time to value, right? You're going to be able to get a lot of value very quickly. 2, very low cost or investment for the returns promised. And 3 is really about being able to become a champion or a hero to that person that is objecting, right? Like, you're going to be able to present real, actionable, personal data that is going to be influential. And we're not talking about heuristics. We're not talking about just sort of best practices there. It's going to be this building, that I'm going to show you information about. And this data is what gives you the capability to do that. Top objectives. It really runs the gambit. It goes all across the board depending on where the backgrounds of the folks are that we talk to. I think that sometimes, we'll see a question mark as to, well, why do I need to, the building, it's the typical kind of thought process of saying, okay, well, the building's running fine as it is, as far as I know, why should we change anything? And, the reality is that we're not changing anything. We're actually providing you with an additional tool belt to see what's going on. I think major concerns are around implementation, around cost, and hopefully we've addressed some of those questions in the webinar today. So I'd say implementation concerns, cost concerns, and then just sort of process in your building's organization to make sure that it's getting on board in the right way.
Great. Thank you, Logan. And then coming back to our Cassidy Turley building, and I'm sure this is a question that a lot of our attendees are thinking as well, is what were the changes that were made to 7050 Pratt Street to achieve improvements? I mean, once you had your data in front of you, what were some of those changes, whether broad or specific, that helped you further?
Yeah. Decreased run times, I think, is probably near the top of the list. Maximizing the use of the economizer, and that was really a programming function on the building automation system. Everything was in place. It just needed to be commissioned. A couple of new strategies was the heating and cooling lockouts that we put in place there. Really cool strategies. We use them over and over everywhere that we can. So when a building, when it's greater than a user adjustable set point, we like to say, of, let's just say 61 degrees outside, the building can't heat. Heat will not come on. So having heating lockouts and cooling lockouts so that you're not cooling when it's cool outside, you're using your economizer, maximizing use of it, locking out cooling, locking out heating based on outside air temps was really the big four things, was that, along with runtime. And there was some runtime issues where things were programmed to shut down and they weren't shutting down. So those were really the big things there.
Okay, great, thank you. And on that theme, I don't know if this is something you had done in your building, but we do have an attendee asking, would plug load data, having that on hand, be helpful, and maybe was it helpful to you in terms of, this more granular data? Is that helpful?
Yes, we moved from centralized real-time metering to system-level real-time metering, and now we have a glimpse at plug and light loads at this same building. And it continues to, now the Energy Star score has grown to an 89 from a 75, and it's been just a constant progression. So we have expanded to system-level metering. Understanding plug loads is what we've done with it at this point. We haven't taken the step of trying to manage the plug load at this point, but what we do have now is the data to say, does this make sense to start to try to manage our plug loads, meaning turning plugs off at night. It's a balancing act, because we do have tenants who have systems connected to those, or simply their computers connected and their IT folks do work at night and we can't shut them off. So understanding how we can manage plug load, but it's powerful in the fact that we have the data we need to start making those kinds of decisions.
Great. And how do you handle that much data? Now that you have this data, after implementing this, can you give kind of some insight into how you handle it and how that helps you going forward?
Yeah, well, that's kind of part of the beauty of having this software platform designed really around energy data and data collection. The way that our approach is to do it on a selective basis, right? So you start at the high level, and you give the user the ability to drill in when they need to. So start with those high-level metrics and drill in based on the flags or based on particular notes of interest that become obvious as you're looking at at the data. But the beautiful thing is that with this approach, right, we're not talking about Excel spreadsheets anymore. We're not talking about manual data entry and that kind of stuff is collected, and that's where some of the real power starts to come in when when organizations start to think about centralizing this across an entire portfolio. And we're certainly seeing that with some of the industry leaders out there today.
Great, thank you. And then can you talk about how easy this is to replicate, this improvement process? How easy is it to replicate in other buildings in your portfolio or on your campus once you've done it once?
We learn valuable lessons at each building, and because many of the buildings we manage are different, it's just great info. So we've created a list of some of those best practices, just kind of one-liners, and it's well over 100 now of ideas that we've learned from different buildings. Anything from managing hot water tanks, coffee pots, to HVAC loads and start times. We do a tremendous amount of in-house training, so we're training our operators on sort of our lessons learned from start times and how we manage them in different times of the year, the shoulder months, taking advantage of those, maximizing use of economizers, preventative maintenance on those systems, really the importance of retro commissioning and recommissioning to make sure things are working like you think they are. So we've taken the data that we've learned at so many different building types, and we use it as training tools in-house to really train our operators that are just starting down that road or are new to the whole idea of real-time data and what you can do with it.
Great, thank you, Lee. Now, if you could, either of you, address this issue. What would you consider? We had talked about how, Logan, you had mentioned how sub-metering is becoming more affordable due to the web-based aspect. So what do you consider, in general, an affordable sub-meter cost for the market?
Yeah, so benchmark. So I guess general benchmarks that I have is, individual pieces of equipment are probably in the $400 to $500 range, nowadays for sub-meters. You could get that down to a little bit more if you're just talking about what's called pulse metering, if you're metering the utility companies. Maybe a little bit more than that once you kind of bundle in all the costs of additional accessories and things like that. But that's generally where a good web-enabled meter is at right now. I think that that's a huge difference than, let's say, 4 years ago, where we were looking at 3 or 4K per meter. Now, keep in mind that's just equipment costs, so there's a little bit of overhead for time and materials for the actual installation, and that's kind of where we gave the original benchmarks in our presentation. That includes everything.
Okay, wonderful. Now we have time for just 1 or 2 more questions. So, Lee, I did want to go back to something that a specific question someone had asked about the lockout function, and you had also touched on it. Can you just explain, when you were talking about understanding the loads throughout the day, was one slide. Can you just explain what you meant in that slide where you had a lockout until 63 degrees setting? What does that mean?
That means the mechanical cooling. So that particular building had an economizer to utilize that nice cool 50-degree air to cool the interior of the building. So the building was running on economizer, and mechanical cooling, the chiller plant, was offline. So the chiller plant wasn't running. From the time the building started at 6 a.m. until that 10:30 or so time frame in the morning, the building operated without any mechanical cooling, took full advantage of that nice, cool, crisp air outside, kept the building cool up until when it said, I can't cool anymore because the outside air temp has just risen too high. Then mechanical cooling is enabled, and those outside air dampers are taken down to a minimum position. That's where it really transitioned over to mechanical cooling. Now my chiller plant's running, and my building is looking more like it has a full load.
Great, thank you. And we'll have time for 1 more question, and this involves a question that's on probably a lot of people's mind is, how does, when the facility has a building management system in place already, and they want to integrate a system such as this with the real-time sub-metering, can you just talk a little bit about the integration, what that entails?
So, this is an interesting conversation point, and it's certainly something that does come up. I would first start by recommending that you don't worry about that at first. This data is extremely valuable, and there's a lot of time and materials and sort of a lag time that goes into integration, because the reason why very often is because we're needing to understand and assess exactly which BMS brand and version you have, what are the capabilities, what are its specific capabilities for integration, and you're dealing with a lot of very unique situations that can add some time and effort to it. So how I would recommend answering that question is do the implementation in 2 stages. Stage 1 is let's get the data collecting, and let's make sure that we're getting as much value out of that data as possible, as quickly as possible. And then step 2, integration with BMS systems for sort of automation purposes is absolutely possible. It's certainly something that can be done, and I would just say that it's sort of that next stage or that next phase in the implementation cycle. The value that you can get just from understanding the information is incredible, and there's no need to wait, for that integration step, but something that can be put on the horizon and in your strategy.
Great. Thank you, Logan. Well, it looks like we're out of time, so that was some great information. I want to thank you, Logan, and thank you, Lee, again, for sharing this insight with us today. And I want to let you all know that a recording of the presentation will be available shortly on the Today's Facility Manager website at todaysfacilitymanager.com. It will also be available on the Aquicore website at aquicore.com. So thanks for joining us, and thank you for your time, and have a great day.